Take a look at families of graphs. So we're going to look at those transformations that we've worked on the past couple days, but now take a look at specific graphs here. So these families of graphs, they're graphs that share similar characteristics, and when I refer to a parent graph, that's in its simplest form, so without any shifts. So for example, here are some parent graphs we'll need to know. This is the graph y equals x. You guys know this one, it's y equals x squared. And it's nice to be able to name a few key points on this one, each graph. So we got 0, 0, 1, 1, negative 1, negative 1. Some good points on this, we got 0, 0, 1, 1, and negative 1, positive 1. We have this next one here, this is y equals x cubed. So once again, it goes through that origin, 0, 0, goes through the coordinate 1, 1, and 1, negative 1. You have your absolute value here. So this one goes through 0, 0, 1, 1, negative 1, positive 1. We have y equals the square root of x, which is 0, 0, 1, 1, and let's see, 2, the square root ends up being a decimal, so we could have 4 and 2 on there. And then this rational function here, y equals 1 over x. And this goes through the coordinates 1, 1, and negative 1, negative 1. And all these other coordinates as well, but these are our nice integer ones. So shifting, we've done that as well. When it's inside parentheses, it's a horizontal. And if it is x plus h versus f of x minus h, you guys know these. It goes to the right and to the left. You guys are getting good at those. Whereas vertical here, if it's f of x minus k, it's moving down. But if it's that function and it's plus k, it's moving up. And then you have your reflection when it's the opposite of your y value. So we remember we always thought of f of x as y. It's flipping over the x-axis. But if you have it inside, that's saying the opposite of x. So that's taking a positive x and switching it to a negative. That's reflect over the y-axis. And this is what is the new part, this compression and expansion. So if that number is on the outside, we have like c times y. That's affecting our vertical, expanding if it's greater than 1, compressing if it's less than 1. And we always multiply that y value just by our c. Whereas if it's inside the parentheses, it's horizontal. And this was where our scale factor is that 1 over c. So it's horizontally if it's greater, because then we're multiplying by 1 over c, that fraction that's smaller than 1. But if it is in between that, it's going to be expanded. For example, if you had f of 1/2 c, or 1/2 x, your scale factor is 1 over 1/2, which is 2. So it ends up being a horizontal expansion. So when we take a look at this, first thing we're asked to do is identify the parent function. Well, our parent function is that 1 over x. So now what's happening to it? Well, the easiest one is going up 2. Minus 3, it's going to the right 3. But what does that 2 do? So we have to think, the 2 isn't directly affecting the x, it's affecting the whole thing, because that's the same as 2 times 1 over x. So that would be a vertical expansion with a scale factor of 2. So when we take a look at this next one here, we're actually going to graph some of these, and we're going to graph some of these from the square root of x. So let's see, we have the square root of x plus 3, and I think it was minus 1 here. Yep. So our parent function is the square root of x. And let's see, some nice coordinates. We said we're 0, 0, 1, 1, and 4, 2. What happened to this function here? Well, let's see, plus 3 moves to the left 3 and down 1. So when we look at this, 0, 0. To the left 3 would become 3, down 1 is negative 1. To the left 3 would be 4, down 1 would be 0. To the left 3 is 7, down 1 would be 1. So we end up with 3, negative 1, 4, 0, 1, 2, 3, 4, 5, 6, 7, 1. And so if we wanted to practice domain and range on this one, we could. What's our domain? Well, our starting x value is at this 3, so x has to be greater than or equal to 3. Where our range, well, the lowest value is negative 1, so y has to be greater than or equal to negative 1. Now the next one, we had y equals 2 times the square root of x minus 1. So once again, that parent function is the square root of x, so those nice coordinates 0, 0, 1, 1, and 4, 2. But what happens to this? Let's see, the minus 1 moves it to the right 1. But what does that 2 do? Well, it's affecting the entire function, so that's a vertical times 2. So to the right 1, 1, 0 stays the same. To the right 1, 2. Vertical times 2 becomes 2. To the right 1 becomes 5. Vertical times 2 would be 4. So we have 1, 0, 2, 2, and 1, 2, 3, 4, 5, 1, 2, 3, 4. So we can see how this one's at vertical expansion. It's getting higher faster. So the domain on this one, let's see, x starts at 1, so greater than or equal to 1. And our range here, it just starts at 0, so y is greater than or equal to 0. Now we're not going to take a look at this last one here. We're just going to graph these two here. So this first one is a parabola, so our parent function is x squared. So nice coordinates on there, 0, 0, 1, 1, and let's see, 1, 2, 3, negative 1, 1. But what happens here? It moved to the right 2 and down 3. So it becomes 2, negative 3, right 2, 3, negative 2, to the right 2, 1, down 3, negative 2. So we got 2, negative 3, 3, negative 2, and 1, negative 2. So we've graphed that one. Now what is this next one asking? It's saying y equals the absolute value of that function. Well, what do we know about absolute value? That distance from 0. So we'll never have any negative values. So it's taking y equals that absolute value. So let's see. Here's our function right here, but we're taking the absolute value. So if we do that, 2, the absolute value would be 3. 3, the absolute value is 2. 1, the absolute value is 2. So it becomes 2, 1, 2, 3, 3 and 2, and 1 and 2. Now, as we make this curve, we might be saying, well, it just flips it. But if we keep this curve going, if we take the absolute value of y, will it ever drop and be negative? Well, no, it won't, because it's positive. So it's going to follow that curve right back up. So what this absolute value does, if there's a parent function plus the absolute value, it makes it so there's no negative y values. We're taking the absolute value, so it flips it above the x-axis.